This video covers 11.3 logarithmic functions. Objective 4, determine the domain of a logarithmic function. In preparation for determining the domain of a logarithmic function, we need to remember what the domain and range of an exponential function is. For exponential functions 2 to the x, this is the graph that you see here, we know that the domain, you can plug in any x value and get an output. It's the range, however, that's restricted. You have to be great. The range is always greater than 0. That graph never touched the x-axis or went below it. Now, we're talking about the inverse of the exponential, which is the logarithmic function. We can generate the graph of it quickly by swapping the ordered pairs, the inverse. If xy is on the graph of the function, then yx is on the inverse. So let's swap all these ordered pairs. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. Negative 1, 1/2 becomes 1/2, negative 1. Negative 2, 1/4 becomes 1/4, negative 2. The graph didn't touch the x-axis, so this graph doesn't touch the y-axis. And so that's what the inverse looks like. And so we'll use this and the fact that the domain and range get swapped to talk about the domain and range of the inverse function f of x. So from objective 3, we saw in the last two problems that the input into a logarithm cannot be less than or equal to 0. We saw that when we plugged in the 0, we got undefined, and when we plugged in negative 5, we got undefined. This tells us that the domain of a logarithm is all real numbers greater than 0. We want numbers that we can plug in and get some nice number out of it. We also saw from these tables above that the outputs of the logarithms can be positive, 0, or negative. Now, from the graph that we just did, we know that the domain of the function 2 to the x is all real numbers and range is greater than 0. And when we looked at the inverse function, which is the log base 2 of x, we know these get swapped so that the range is all real numbers and the domain is x greater than 0. So using the fact that domain and range get swapped when talking about inverse functions, we can now say that the domain of the function is the range of the inverse. The range of the function is the domain of the inverse. So now things are swapped. The domain of a logarithmic function is 0 to positive infinity, and the range of the logarithmic function is all real numbers. Finding the domain of a logarithmic function, we have to ensure that the expression inside the log is always greater than 0. So example 3, the domain of this logarithmic function, we must ensure that we only take the log of something greater than 0. And so that we would achieve that by saying that x must be greater than negative 8. If you put anything less than or equal to negative 8, you'll be taking the log of a negative number or 0. If we have log base 3 of 5 minus 2x, we need to ensure that 5 minus 2x is greater than 0 to get an output. We subtract 5 from both sides, and now we divide by negative 2. Flipping over the symbol, we get x is less than 5/2. Here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. The domain of a logarithmic function, we must ensure that the expression inside the log is always greater than 0. We want to ensure that x minus 10 is greater than 0, which tells us that x must be greater than 10. So the domain of this logarithmic function is all real numbers greater than 10. You could also write this in interval notation. 10 to infinity. And if we have f of x equals log base 3 of 3x plus 4, we want to ensure that the expression inside the log is greater than 0. So we would subtract 4 from both sides and divide by 3, giving us x is greater than negative 4/3. And remember, the logarithms, the domain being restricted, that means we won't have a graph for all x's. We will only have a graph for the x values in its domain. And that's what we look at in the next video, Objective 5, Graphing Logarithmic Functions. And this concludes the video for section 11.3, Logarithmic Functions. Objective 4, determine the domain of a logarithmic function.